Solving Equations Part 2. Go ahead and have your paper out, or remember, you can always access the learning guide in the description below. The lesson opener is for you to go ahead and give it a try. Remember, you must communicate mathematically, so that means go ahead and write it out. Show all steps. That is so important in this class, and we're going to hold you to it. Pause the video, try, come back and check. All right, go ahead and check your answers. If you need to, pause it again and look at every single step. Remember on that first one, we could have done it more than one way. So I could have started by adding the B and dividing out the A. So if you have that and if it's an equivalent answer, it's totally fine.
All right, so moving on to the lesson. Number one, we need to communicate mathematically to solve for each unknown variable. This is the same thing we've already done. Now we're just gonna get a rational solution for each equation. So for this first one, I see a lot going on. I can't just grab that y right now and start solving for it because I have these parentheses and everything. So what I like to do is clean up the equation. What that means is if there's something I can distribute, I go ahead and distribute. Or if there's a like terms on the left side, I go ahead and combine my like terms. Or if they're on the right side, I combine them there. Before I actually move my variables to one side and start solving, cleaning up the equation. So let's try that. First thing I'm going to do is distribute the -2 across y minus 1. -2y, and then if I distribute the -2 to -1, I'm going to get +2. Be careful, that's where mistakes happen. Then I have -17 plus y. My next goal would be to make sure I get all my variables to one side so that I can start solving. So I could move -2y to this side, or I could move y to this side. Since this is negative, I like adding, so I'm going to add my 2y to the other side. These would go away, so I'd get 2 equals -17, and then y plus 2y, so 1y plus 2y is 3y. Now I have all my variables to one side, and all I have to do now is start to solve for y. So isolating y, so I'm going to get rid of this 17, -17, add 17 to the other side, okay? That's going to be 19 here. These would cancel away, and I would have 3y left behind. Last step would be to get this y officially by itself by dividing that 3 off of it. So I'm going to have 19 over 3 equals y. The key here is notice my vertical steps. I'm showing each step to communicate mathematically appropriately. Remember, we've already talked about that. Communicating mathematically here is key. You need to do that. So showing your work as you get down to a solution. Okay, moving on to this next example. I don't see any parentheses involved. So first thing I'm going to do is I see some x's and some like terms on the left and right side. So I'm just going to combine like terms before I start moving anything around. So 7x minus 4x is 3x plus 6 equals, on the right side, I see a 12 and a -8 that are like terms, so I can do 4 plus 3x, or I could write that as 3x plus 4. Okay, now the major goal is to get all my variables to one side. So I have this 3x here, I could move that to this side, or I can move this 3x to this side. Doesn't matter which I choose. I'm just gonna stick to the same way as I did before. This is a 3x, so since it's a positive 3x, I would subtract it to the other side. So I'm going to subtract it over here. So this 3x is going to cancel away. I'm going to have 6 left equals, I have this 4 left, and then 3x minus 3x again, that's also going to cancel away. So I end up with this weird line where it says 6 equals 4. 6 does not equal 4. Like, this is literally not a true statement. If I go back and look at my work, I'm a little suspicious because I'm like, well, this didn't work out, so did I make a mistake? So if I go back and start to check things over, looks like everything I did was correct. So if this happens to us, we just say that there is no solution. There is no x that I could possibly plug into this original equation to make this equation true. So don't be afraid of that happening. Just go back, check your steps, and if they're looking right, you have no solution. Okay, last example. Okay, so this one's gonna combine all the skills we've used so far. So we've learned, okay, we gotta distribute when we see those parentheses, we gotta combine like terms, we gotta move our variables to one side. I see parentheses, so that's gonna be the first thing I take care of right away, is I'm gonna get rid of those parentheses by distributing the 3 here and the 2 here. So 2n plus 3n, I'm going to be really careful about not writing -4 next. I'm going to go 3 times -4 is -12 equals 2n times 2n is 4n. Again, make sure you distribute that 2 all the way across through both terms. So -12 plus n. Okay, so now that I've gotten rid of all my parentheses, I can go ahead and combine like terms on each side, and then I'm going to be moving variables to one side. So combine like terms on this side, I have a 2n plus a 3n. So that's a 5n minus 12 equals 4n minus 12, those aren't like terms, but hey, I have a 1n here, so then I can combine these two terms here. So 4n plus n would be 5n. Whoa, minus 12. I'm already a little worried that I have 5n minus 12 equals 5n minus 12. Not sure what to do with that, but if I keep rolling like I have been and just continue to solve, my next goal would be to move all my variables to one side. So I'm just gonna move this 5n to the other side. So minus 5n minus 5n. This would cancel, minus 12 equals, this would cancel, minus 12. So negative 12 equals negative 12. Well, before we had 6 equals 4 and we said no solution. Does negative 12 equal negative 12? That's actually a true statement. So when this happens, it means that no matter which n or what number n I plug into the original, every single one of them is going to work. Any number I could think of to plug in is going to work in this equation. So we're gonna say infinitely many solutions. Any possible solution I can think of in this equation would work. All right, so I've done these 3 equations with you, so now it's your turn to try 3 on your own. Pause, take a moment, try all 3, and then Mrs. Peart's gonna go over those with you.
All right, let's see how you did. First line, we went ahead and distributed the 2's on both sides. Then we combined like terms, 9x minus 2 equals 12x plus 8. Then of course I want to get the variables together. Now technically I can subtract the 9x and move it over, or subtract the 12x and move it over. It doesn't matter, but I always like to keep the coefficient positive if possible. So I went ahead and subtracted the 9x. At that point I'm at negative 2 equals 3x plus 8. I subtract 8, negative 2 minus 8 is negative 10, equals 3x, divide out the 3, and of course x equals negative 10/3. I went ahead and flipped it around using the symmetric property. The next one, we add the 12. Ooh, wait a second, I want to emphasize something here. Let's remember to hug it out, right? That w plus 1, I can't just go, oh, let's add or subtract that 1 away. So we go ahead and add the 12. We get w plus 1 hugged out, divided by 7. And then of course I want to get rid of that divide by 7. So multiply by 7 on both sides. At that point, I can divide out the 7's on the left-hand side. We often say cancel, but let's keep in mind what the operation is. And we are left with w plus 1 equals 49, which of course when we subtract 1, we get w is 48. And then last but not least, went ahead and combined like terms on both sides. You might have already seen what was going to happen, but after you subtract that 15c from both sides, we get negative 14 equals negative 5, which of course is not true. So we say that does not equal, and therefore there is no solution to this problem. I hope you did great. Next, we have a couple of challenge problems for you. I have a feeling you can do them.